is part 2 of the ACT corrections for test 59F. And as I said before, we're going to do this one last problem that's dealing with elementary algebra, and then we'll switch over to the intermediate algebra and coordinate geometry. So for number 41, we're told that we have a over 30 plus b over 105, which equals 7a plus 2b over x. We also know that a, b, and x are integers and that they're greater than 1, and it's our job to figure out what x equals. So if we consider what's on the left-hand side and on the right-hand side, we see the a's and we see the b's, but now instead of being two separate fractions, it's one combined fraction. So that tells us that this x is going to be a common denominator, the least common denominator, hopefully, for 30 and 105 for these two fractions. So let's go ahead and consider how we can find the value of x. The most easiest way to do this, because we're considering time, is to think about this fraction on the right-hand side as actually two fractions that have been melded into one. So if we have 7a plus 2b, and that's all over x, that's really the same as 7a over x plus 2b over x. And we just combine them into one fraction here. So let's see what happens if we solve for x based off of what we know of a and solve for x based off of what we know for b. So if we look at a over 30, let's compare that to the 7a over x. So we have a over 30 equals 7a over x. Goodness, this looks like a proportional problem. So let's go ahead and solve it out for x. So we cross multiply. There we go. So now we have a times x, and then we have 30 times 7a. 30 times 7a. So if we do a little bit of cleanup work, we can multiply the 30 and the 7 along with the a. So that gives us 210a equals ax. Well, if you notice, both sides have an a. So if we divide both sides by a, we get x equals 210. Well, that's one of our answer choices, so it looks like this is probably it. Let's check it, however, with the other fraction that we have here. Let's confirm it for sure. So if we go through, we're going to do the same process with the b over 105. So you have b over 105 equals 2b over x. Now if this works, we should get the same value for x as what we got when we worked out this part with the a's. So let's go ahead and see what happens. So it's a set of proportions. We can cross multiply. So that gives us bx equals 105 times 2b. Then we're going to take that 105, multiply it to the 2 and the b, which gives us 210. This looks promising. Bx over there. Divide both sides this time by b, because both sides are multiplied by b, and we get x equals 210. Fabulous. That tells us for sure that yes, C is the correct answer for this question. So that handles the elementary algebra. Let's go back and consider the intermediate algebra questions and geometry. So we start off with number 25. We know that the sides of a square are 3 centimeters long. One vertex of the square is at 3, 0 on a square coordinate grid marked in centimeter units. That just means we have an xy plane. So if I draw it like this, and we know that 3, 0 is one of the points, or one of the vertices for our square. So they're asking which of the following points could be a vertex of the square. So if we think about what a square looks like, we know that a square has the same length of sides, and we know as a result the distance between each of those sides should be the same. So the sides of this square are 3 centimeters long, so that means I have a distance of 3 centimeters here, 3 centimeters there, 3 centimeters, and 3 centimeters. So if I'm thinking of the distance and I'm thinking of a coordinate plane, we want to consider distance formula. Now we could go the simple route. One of these answers may just be a simple, I see a difference of 3, and based off of how my points are set up, it has a distance of 3. Or we may have to do something a little bit more complicated. But let's see what we can get out of what we have here. So we know that the point we're looking at is 3, 0. So that means if I'm at 3, I'm going 1, 2, 3, so I'm right here, and my y value is 0, so I'm not heading up or down, I'm right there at 3, 0. And we're told that there should be a distance of 3 to the next vertex if it's next to it. Now, of course, if we were traveling from one corner of the square to the other, we would have a distance of 3 root 2. If you're not following how we know that it's a distance of 3 root 2, just let me know and I'll make sure that we discuss the next time we meet. So like I said, you would have between these two diagonals a distance of 3 root 2. So let's go ahead and look at the distance formula and use that to evaluate these different points. If we're lucky, we should hit our value pretty early. So let's go ahead and write down the distance formula. We know that distance formula says that the distance between 2 points is going to be x2 minus x1 squared plus y2 minus y1 squared. And again, this is talking about your coordinate points, and we just plop those values in there and come up with our distance. So let's try this with the first point. We have 6, 0. So that means if we plug this into our equation, or our formula rather, we have the square root of, let's look at those x values first. We'd have 6 minus 3 squared plus, looking at the y value, so we have a 0 and a 0. So 0 minus 0, which is essentially 0, squared. So this portion just cancels out and becomes a 0. 6 minus 3, we do parentheses first, so that gives us a 3. And it's 3 squared. And we know that 3 squared is 9. And what's the square root of 3? 3. That's good, because A is our answer choice. Now we could go through the same process with these other coordinate points, and none of them will give us a distance of 3. If you want to go through and check them, you certainly can, but for the sake of time, I'm going to move on to the next problem. Just know that for this kind of problem, distance formula is what's going to help you to determine where your vertices are with this square. So now we're going to look at number 38. In the standard xy coordinate plane, the center of a circle shown below lies on the x-axis at x equals 4. So in layman's terms, that means that this point, where the center of the circle is 4, 0. If the circle is tangent to the y-axis, which of the following is an equation of the circle? Now this part where it says that it's tangent to the y-axis, it means that the circle touches at just exactly one point to the y-axis. It doesn't cut through like you see this circle cutting through the x-axis here and here. It only touches the y-axis at just one point. And in fact, that's quite useful if we know the equation for a circle. If you haven't seen this equation before, no worries. It's normally something that you find in Algebra 2 and pre-calculus. So we'll walk through it and explain what the different pieces are. So when we're looking at the equation of a circle, it's going to be x minus h quantity squared plus y minus k quantity squared equals r squared. And it makes sense of what the h, the k, and the r are talking about. The r is going to be your radius, so whatever distance it is from the center of your circle to the edge of your circle, that's your radius. And then the h and the k are actually where your center is. So we'd say that the center is at coordinate point h, k. So we can take the information we have of the center coordinate point, and we actually know the radius. We know that it goes from 4, 0 out to this point, which is the origin, 0, 0. So we know that the distance here is a radius of 4. So we can use that information to fill in this formula and determine which of these answer choices is correct. So let's go ahead and do just that. So we have x minus h squared, I'm going to write it down here again, x minus h squared plus y minus k squared equals r squared. So let's change out some values. Well, we know that the radius is 4, so instead of having r squared, we can put in 4 squared. We know that because the center is 4, 0, and we're looking for h, k, h is then 4, and k is 0. So that means where I have my h, I can change that out to a 4. And where I have my k, I can change that one out to a 0. So let's do a little bit of cleanup, just a wee bit, and see if it matches to any of these. And in fact, you know what? We can do it just straight from here. So we have 4 squared, not just a single 4. So that means instead of having 4 squared, we should see 16. So hopefully you're all right with me erasing this. I'm going to replace this with a 16. So let's see which of these will match. Well, I know it's not going to be F or J because I have just simply a 4. And then I also know that it's not going to be H because look, it has a minus between this X portion and the Y portion, and we should have a plus. Any subtraction should be inside of our parentheses, not outside. So sorry H, away you go. We also can see that if we look at K, it has x squared. It doesn't have x minus 4 squared. In fact, it has y minus 4 squared. And we know that's not correct based off of the formula. It's going to be the x coordinate in this set and the y coordinate in this set. Our x was 4, our y was 0, so it should be a 4 here and a 0 here. So sorry, K, you're not it either. So that means our answer choice is G. The x minus 4 squared, x minus 4 squared. Now this has a y squared, this has y minus 0, but y minus 0 is just y. So we can rewrite this to just simply y squared, and that equals 16. So that takes care of those two. Now we have 2 more problems left to go through. Should be able to get through one of those, and if I can't do the second one on this video, I'll just create a third part so we have it all wrapped up. So let's go ahead and get started with number 46. So on 46, we're told that we should consider I squared to equal -1, and as a result, what is 4 plus I quantity squared? Well, this is a binomial expansion question. You remember those problems from Algebra 1 where they'd have something like x plus 2 squared, and you go, okay, well I can use FOIL on it, or you may have a special rule that you used. But it just means I have x plus 2 times x plus 2, and from there you could use FOIL, or you could use your special case information, whichever. In this case, we're going to go ahead and do the FOIL method. It's just squaring, so it's not too bad. So let's go ahead and write it out and see what we get. Keeping in mind that anytime the I is squared, we can replace it with a -1. So we have 4 plus I quantity squared, which is going to be the same as 4 plus I times 4 plus I. And then we'll FOIL from here. So I have first, so 4 times 4 gives me 16. Outer, so 4 and I, that gives me a positive 4I. Inner, so I and 4, that gives me a positive 4I as well. And then I times I gives me a positive I squared. Ooh, look, I squared, which means I can replace it with a -1. So let's do that in this next step. I have 16 and I have -1 over here. Now the 4i and the 4i, they're the same type of terms, so I can combine them. They're like terms. So that means I have 16 plus 8i minus 1. Do a little bit of extra cleanup work. I have 16 and a -1, so 16 minus 1 gives me 15, and then that 8i stays right where it is. So that tells me my answer choice is J. Good stuff. So again, for this problem, it was about finding that I squared and changing it to a -1, and hopefully you still remember the binomial rules. If not, we can do some practice problems with those to make sure we're really solid on that, because this is more of a Algebra 1 going into Algebra 2 question because of the I squared part. Well, it looks like I have just a few moments left, and since I don't want to rush through this next one, I'll show you that it's going to be number 49, and I'll finish up another video.